recording. It's week 9, and that means the quarter is almost over. Some of you guys have taken the kind of the practice exam. The practice exam is intended to be easy, please don't think that it is indicative of what the actual final exam will be. But it seems to be, at least for those who've taken it, it seems to be working for the most part, using HackerRank as kind of a tool for testing things. And again, if you're interested in Python programming and becoming more proficient, I think HackerRank, is a reasonable place to practice. You get some coding experience and exercises. HackerRank alone is probably not the best place to learn Python, but certainly it's a good place to practice. And then and they have a series of different challenges and that you can complete and things like that. And there's also a good discussion boards. Like if you get stuck or after you finish a solution, you can check the discussion boards, and usually people have shared their solutions and what they've done, and you'll say, oh yeah, that's a pretty good way to go. Okay. Anyway, today we're going to keep moving on in kind of the data manipulation side, data analysis side, and today we'll look at visualization with matplotlib. And so Python has some tools that you can use to create plots of your data, and it's the kind of the most commonly used package is matplotlib. And it's okay. I'm a ggplot fanboy, so I very much enjoy ggplot and R. And so if you compare matplotlib to ggplot, in my opinion, it's not as great. But it gets the job done. It gets the job done. It's called matplot because it's based off of, I guess, MATLAB, and I'm not familiar with MATLAB. So apparently, if you want to make plots in MATLAB, it's similar to what matplotlib does. But anyway, this is what we do. So anyway, we're going to import NumPy and pandas, and then from matplotlib, kind of the convention is to import pyplot as PLT. And so you'll see a lot of references to PLT, just like when we refer to NumPy, we call it NP, and pandas is PD. So we'll do that. And the best way to learn matplotlib is to look at examples of other plots, and you say, oh yeah, I want to do something like that, and you try to learn kind of the functions that are being used, and you adapt it to your needs, right? So so here I'm going to create basically a sequence of x values that go from 0 to 2 pi. Okay, so 500 equally spaced values from 0 to 2 pi. And then I'm going to say calculate y as the sine of x. And if you create a plot, you can do plt.plot x and y. You give it the title sine of x. The x limits go from 0 to 2 pi. And you do plt.show to show the plot, and boom, you get the sine of x. Let me, can I zoom out a little bit? It doesn't work out as well as I thought. Okay. Here, I'm taking values 0 through 4, all right, and then I got random integers. So I got 0, 1, 2, 3, 4, and then 4, 8, 0, 9, 8, and it gets plotted like that, 4, 8, 0, 9, 8. And by default, when you call plt.plot, it connects the dots together with a line. So that's why this is connected, because what this really is, it's a sequence of 500 points, and this is a sequence of 500 this is a sequence of 500 values. Excuse me for a second. Okay, so this is actually a sequence of 500 points, and they are they're connected. So the default behavior is that the points get connected. Here we have so the default is that the 5 points here are connected. If you don't want them connected, then don't call plot. You call scatter. Okay, PLT. So from matplotlib pyplot.scatter, and you'll get the same 5 points. These are the same 5 points, but not connected. They show up as a scatter plot. Okay, and you can add options and whatnot there. If you've got a whole bunch of values, so here I did random normal. I said 10,000 random normal values. You can create a histogram, plt.hist. Okay, and you can set how many bins you want. So here it is with 30 bins, and we can see 95% is within 2 and -2, and almost everyone 99.7 is within 3 and -3. So. You can do multiple plots on one thing, right? So these are just the basics, right? So here I said, x's are values of 0 to 2 pi. Y is going to be the sine of x. Z is the tangent of x. W is cosine of x. All right. So if I plot sine of x along with tangent x, tangent x goes off to infinity and negative infinity. It doesn't actually go off to infinity. So what's happening is, because this is not actually it's not actually continuous, right? These are 500 linearly spaced finite sequences. So we're going to get something close to say 90 degrees, or pi over 2, but not exactly so. So when you calculate the tangent of say pi over 2, you're getting something, maybe like 120 or something. And then you get something just a little bit past pi over 2, which would be negative infinity, but it's not exactly that. It's, you get something like negative 300, all right? So just, you kind of get this thing. And it dwarfs, right? Sine of x goes between 0 and 1. So that it just kind of dwarfs the values between there and there. But here is the y is the sine of x in blue, and w is cosine of x in orange. And you can specify, the color of the lines you want and whatever. You can set your x limits, and there you go, sine of x and cosine of x. You can create subplots. This didn't work out. So a subplot basically allows you to kind of create. So here's like 4 plots here, right? And so to call subplot, you say I want 2 rows, 2 columns, and then you refer to which plot you want, right? So you can do 2, 2, 1. So this is confusing, because everything else in Python is 0 indexed. But here, when you do subplots, this is 1, 2, 3, 4, okay? So this is subplot 1, this is subplot 2, so they go across the rows and things like that. So you say so create the subplots, 2 rows, 2 columns, And in the first plot, which is this one, we want sine of x, x and y. 2 rows, 2 columns. In the second plot, we want x and w, which will make cosine of x. Here, 2, 2, 3, we want x and z, which will be tangent of x. And here in this plot, 2, 2, 4, we want to plot x and y and x and w, which will look like this. And then finally, we call plt.show, and it plots all 4 plots. Okay, so you can do that to make subplots. Later on, I'll show you kind of a more complicated example of a subplot. I don't know. I don't know if anybody, no, I shouldn't say nobody uses subplots, but they're kind of a pain, right? It's a little bit tedious. It's a little bit not fun. Sometimes you need to do it, right? Sometimes you need to create multiple plots in one thing, but it's not fun. Okay, so we've seen a couple things. One, back here, I modified the x limits, and here you can modify the title. You can modify the x-axis label, the y-axis label, things like that, right? I can't remember any of these things. Like, what do I use to do this? So constantly, like, if I don't use matplotlib for a couple of weeks, and then I say, all right, now it's time to make a graph, I'm like, I can't remember anything. So I always have to type in matplotlib change x-axis label, right? So I'll do this like this, and then this is x-axis labels. But I'm constantly, there's no shame in this, right? There's no shame in going to Google and saying, oh, how do I do this? And so this is the x ticks and stuff like that. And so I can never remember this, right? And so, you know, I don't expect you guys to like memorize everything, right? It's like only if you're using it every day, then you'll like remember everything. But then it's like, oh, how do I do this? You know, so just you know, just search Google, okay? So it's stuff you can do, and you might there might be stuff I don't even talk about, and you might be like, you know, I think that should be possible, right? How can I do that? So just type it in, right? Just type in matplotlib and how you go about doing it. Okay, here, what happened here? My x limits didn't work. Oh, I guess I can't put it inside. I think I messed something up here. Oh, it's not right. That is not right. How did I do this? Okay, so we're going to generate that. And then let's do this. I don't know why my x limits aren't working. Okay, this is strange. All right, you can use something called axis, and this will create equal aspect ratio. So you know this is a little bit of an exaggerated sine curve, and so aspect ratio will force this distance from 0 to 1 to be the same here, right? So if you plot a circle, it'll look like a circle. Here you have a few options. So if you wanted to do, so it works here. Am I missing something here? x limits 0 to pi over 2. I don't know. Okay. Here, I say, you know what, let's just look from 0 to 0.2. and here we're plotting basically the sine and the cosine values. And here I choose scatter. So normally it's connected with a line, but you can choose marker D. D will do diamonds. Marker H will do hexagons. And you can choose different symbols here, right? So if you want to create a scatter plot with different symbols, you can do that. There's colors, named colors that you can choose, and like regular colors like red, blue, green, those are pretty straightforward. And then they have a selection of named colors that it's like impossible to know what they are. So again, you have to kind of look at matplotlib named colors, and you'll have a kind of a list. And I think I've got list of named colors. And so here are basically some of the color names that you can choose. So here's red, dark red, and maroon, which on my screen looks almost the same, maybe. And then, you know, gray is spelled with an E and an A. I don't know which one's the correct spelling of gray, but it accepts both, okay? And so these are all the named colors that you have in Matplotlib. And then if you're lazy and you only want to type in one letter for a color, you can choose from these 7, right? Or 8. Blue, green, red, cyan, magenta, yellow, black, and white. So, so anyway, these are your named colors that you can choose here. Matplotlib also allows you to plot 2-dimensional functions, okay? So there's a function called mesh grid. Mesh grid will kind of set up a bunch of coordinates of x and y. So here I've got 0, 0, 1, 2, 3, and minus 1, 0, 1, 2. And what I'm going to do is I'm going to create a mesh grid, and that will kind of create a x broadcast and y broadcast into a 4x4, right? So x is 0, 1, 2, 3, and y is minus 1, 0, 1, 2. And this will broadcast it into each of these into a 4x4. And then you can throw these things, big X and big Y, into some function of 2 variables, right? And it's going to apply it element-wise, right? So this is going to be 0 times minus 1. And this is 1 times minus 1. And then we get 2 times minus 1 and 3 times minus 1. And then this is 0 times 0, 1 times 0, 2 times 0, 3 times 0. This is 0, 1, 2, 3 times 1. And this is 0, 1, 2, 3 times 2, okay? So this is the result of doing the mesh grid operation. And so anyway, I'm going to do basically this idea here with a mesh grid, except I'm going to go from minus 3 to 3, length 101, minus 3 to 3, length 101. We're going to produce the mesh grid. And what is this? This is basically exponential distribution of x. And I'm sorry, not exponential. This is basically a normal distribution for x. And this is a normal distribution for y, okay, without the terms that make it, without the normalizing constants. It's just basically a normal distribution for x and y. And then so if I take the product of these 2 things, we're basically going to get the product of 2 normal distributions, or a multivariate normal distribution with a identity matrix for the covariance, except it hasn't been normalized. And you can say, let's take a look at this. So Z is going to be a grid 101 by 101, and you can create contour plots. All right, so this is basically a two-dimensional, three-dimensional normal. It looks like this. Let me see. It looks like this thing right here. Whatever that thing is, okay? But we're looking at it top down, okay? We're looking at it top down. Or kind of like this, except as circle, right? So this exhibits covariance, but we're just getting kind of the contour lines here. You can also do ImShow, which will kind of create this kind of colored plot. Kind of, it's kind of like this. It's colored based on the tiers, the height, the altitude. So those are some basic features here, right? Okay, so we talked about color options. So single letter colors, blue, green, red. You can name your plot lines, or you can color them that way. So this is your single color options, and then again, the named colors are all listed here that you can do, right? There's different line types, okay? You can do a solid line, dash dot, and dot dot, okay? And it's kind of funny the way you say the line style. You don't say like line type 1, 2, or 3. You kind of have a symbolic representation of what these things are. And that's what they look like, okay? The default behavior is that if you don't specify the color and you're plotting multiple lines, Matplotlib will automatically choose different colors for you, okay? And by default, it goes blue, yellow, green, red. And you've got more, whoops. Okay, these are the different line styles. And I think that's all 4 of them. Other stuff, right? So you can specify the figure size, okay? So before you create the plot, you can do plt.figure, right? And then if again, you can matplotlib figure, right? And this will bring up the documentation, and there's all sorts of stuff that you can specify. And so here I'm showing the figure size, okay? The default is this, 644.8, but you can choose different things, and there's, I don't know, other options that you can mess with, okay? And so anyway, here I pick 100 random uniform values from 0 to 1, and I make a scatter plot, and there you go. This is your scatter plot. We add a title equally equal axis here. All right, things you can do, right? So here I am going to create a vector. I've got 100 dots, and I'm going to create a vector of length 100 to specify different sizes. So the sizes will either be 0, 100, 200, 300, 400, 500, 600, 700, 800, or 900, okay? So these are the different sizes. And then here I've got basically 5 different colors, 0, 1, 2, 3, 4, and 5. So I've got these 2 vectors, one to represent colors and one to represent the size. And so for the colors, using these integers, basically I'm going to subset the these letters R, B, G, M, Y using these integers, right? So 201 becomes G, R, and B, right? G, R, B, and it goes through and it fills this out. So now I got basically an array of letters that I'm going to use for colors, and I got an array of numbers that I'm going to use for size. All right, and then, so when you create your scatter plot, here, this part's the same, plt.scatter xy. So that's the same as back here, plt scatter xy. And if you look at the distribution, the spread of all of these dots, like here you'll notice like 3 dots in a row and kind of this triangle down in the corner. It's the exact same layout here, right? The 3 dots in a row, except I think size 0 basically killed off one of the dots, and then the 3 dots in the triangle in the corner will do that. So here I'm going to say S for size is equal to the vector Z, C for color is equal the array C for color, and then alpha will set the transparency. Probably what I should have done. So instead of on 1 through 11 here. Okay. So there's our dots, 3 dots in a row in the corner. We'll take that and that. All right, so 3 dots and then in the corner here. And this way I don't get a dot that gets zeroed out here. Size 0 will make the dot go away. All right, and then similarly, you can also change the marker. You can say instead of circles, I want stars, okay? And we basically have the same plot as this, except now I have stars, and suddenly I feel happy because stars make you happy. All right, so so this is exciting, and you can change the marker. We saw diamonds and hexagons earlier, and you have all of these options here. You can do points and pixels and circles and up triangles and down triangles and left and right triangles. I don't know, squares and pentagons. But of course, you know, again, you're not going to remember any of this stuff. So you're going to matplotlib plot character, right? And then you go, oh yeah, it's markers, and these are the different shapes that you can do. And then I think giving away matplotlib custom marker. There's a way to do it, right? Oh, okay, yeah. So here, somehow, look, they made little shamrocks here, which I don't know what the use of this is, but it's fun, right? So somehow, how do they do this? Marker is R club suit. Okay, I don't know, something in here, right? So you can do it. Here, if you want to, you can add a legend, right? So I'm going to do, we're going to take some 10 points, and I'm going to plot them with red, and the marker is stars, okay? And then the label, we're going to call it group A, right? So here I'm plotting this, and I call scatter again. So here, this will create a scatter plot of 1 set of points. And if you call plt.scatter without calling like a new figure or something, it's going to add the points right to the same plot. Okay, and here we call it group B. And then you can say make a legend, right? And then legend will say, oh, you gave me a label of group A and group B, and it adds the thing here. Okay. Now the default is it puts the legend inside the box. And there's a way to get it outside the box. Again, I don't remember. So we're going to do matplotlib legend outside. All right, so this is, you can see like, I'm not the only one who wants to do this, right? So legend outside the plot. You can check all of these things, right? And you say, well, how do I do this? Oh, look, B box to anchor. and you just try some of these things out, right? This is the life of programming, is you forget how to do something basic and you look up online and you go, oh yes, thank you, Stack Overflow. As long as your question is not like too crazy complicated, you can generally find the answer very quickly in the first couple of results on Google. All right. Okay, so you can do complicated layouts with subplots. I don't know if anybody really does this, to be honest. You can do it. Should you do it? I don't know. All right. It's a lot of work for not a lot of payoff. Just make like 4 different plots. But if you need to do it, right? Like you're trying to publish some kind of thing and you want, right? So here, this is subplots, 2 rows, 3 columns, and then this is plot 1, 2, 3, 4, 5, and 6, right? So you got, you can do this. And what you can do is you can use something called grid spec, all right? And I don't feel like getting into this. Okay, so you can do grid spec, which will create 2, 3, all right? 2 rows, 3 columns. And here you can say in subplot in the grid 0, 0, that's, so this is all the more worse is, so when you do regular old subplots, it numbers them 1, 2, 3, 4, 5, 6. But then when you do grid spec, it's 0 indexed. So this is the 0, 0. This is the 0, 1, and this is the 0, 2, right? So here, we are going to do 0, 0 goes up here, and we're going to put in a scatter plot. Okay, and then grid 1 to 2, right? The slice is technically 1, 3, all right? So in grid 0, row 0, slice 1, 3, which is these two, you can put a histogram, and it's going to kind of put those two together. And here we're going to do grid row index 1, and then the slice goes up to 2, which will be this, and that we're going to put in another histogram. And then here I just put in something else here, and boom. Okay, so you can create this a little bit more complicated plot this way. And as you can see, it's quite tedious, but it's doable, right? So these options do exist in case you want to create some kind of grid specification, and you can do like, I want a 10 by 10 grid, and you know, in these spots I want this, and in this column I want over here, and over here, you know, if you want to create some kind of complicated plot layout, you can do it. You can do it. Okay. And you can read more about how to go about doing something like that. All right. We saw histograms earlier. Your basic histogram, you just do pld.hist of whatever data it is, right? So this is just assuming we've got some kind of NumPy array of numbers in here, right? It's 1,000 random normal distribution numbers, look like that. You can choose things, right? Bins equals 25. I always get this mixed up when I'm switching between R and Python. Sometimes I'll type in bins in R and it doesn't work because R uses breaks as the option, and then sometimes in Python I'll type in breaks and it doesn't work, and it's just, you know, oh yeah, why is this not working, right? So you got bins and you got breaks. So anyway, with Python it's bins, okay? Alpha will reduce the transparency or increase the transparency of the thing. You can change the thing. So the color on here is going to be, so R calls this fill, and an edge color, R calls the edge color color, and then this is called fill. But on matplotlib, this is the color, steel blue, and the edge color is black, and you get a histogram that looks like this. You can do other stuff. The histogram type step filled, and you get kind of this outline without the lines in between, you know, whatever you want to do, right? So this is steel blue with alpha equal to 1, full no transparency. Steel blue with alpha 0.5 is like a lighter shade. Okay, and then again, everything, look up the documentation. That's the moral of the story. All right. Here I'm generating a whole bunch of normal numbers. So I got centered at 0, standard deviation 0.8. I want 10,000 of these numbers. Centered at -2. Okay, standard deviation of 1. That's this. Standard centered at 3. Standard deviation of 2. That's going to be this. We're going to make a histogram. Okay, and so notice, look what I've done. Okay, so I've created a dictionary, and we're going to call this the quargs. Okay, so so remember this. You can give it kind of keyword arguments here, variable length. So all of these things will have histogram type to be step filled, alpha to be 0.3, density to be true, bins to be 20, edge color to be black. Okay, and so these are all gathered in quargs. So rather than having, right? So I could type all of these options in every single call to plot plt.hist, right? So I can do plt.hist plot x1, and I want histogram step filled, alpha 0.3, density true, bins 20, edge color equals black. I can do that here, or I can just do star quargs, okay, which will gather and spread these out into here, okay, and then we'll just say color is navy, and that produces this one. PLT hist, star quargs, color purple, and we get this. PLT hist x3 star quargs, and it plots that, okay? So this is kind of a neat thing that you can do, right? In Python, you can kind of gather multiple arguments together in a dictionary and just throw the dictionary into the function, and it's going to use them as the arguments in the plot. Okay, so that's kind of neat. Okay, again, if you're using matplotlib here. Here's a 2D histogram. So here, Python has a way to generate values from a multivariate normal. Okay, so here I've got mean 0, 0, and the multivariate normal will give it this covariance matrix. Okay, so I guess I closed my multivariate normal, but anyway, this is kind of your two-dimensional density plot. Okay, so you say I want my 2D histogram. Okay, and this is what we'll do. You can kind of get this sci-fi look by using histograms rather than rectangles, right? So this looks more like a pixelated image, and this looks more like, I don't know, some kind of map in a sci-fi thing. Okay, hexagon map, right? Like we're playing Civ or something, and you can do this. Okay, so so that will be a hex bin thing, right? And again, if you don't remember any of this thing, you can just say like, oh, I remember seeing something like that, right? So you can be like matplotlib, you can say 2D histogram, and you go, oh, how do I do this? So here's the two-dimensional histogram. Let's click this thing, and you can kind of read through it. So this is histogram 2D. You can do 2D histogram with hexagons, and then you go, oh, what is this? And then you click hex bin, right? So usually you just have to kind of remember what you saw and say, I want to do something like that, right? Are we going to run out of time? No, we got a little bit of time. All right. So pandas works with matplotlib, and you can plot things by calling plot directly on objects in pandas here, right? So here, first I'm going to create a series. I'm going to call this TS because it's a time series, and we're going to take we're going to create a date range using pandas, starting on January 1, 2000, and we're going to ask for 1,000 days. Okay, so 1,000 days later is September 26th, 2002. And here I just say, give me 1,000 random normal numbers, okay? Numbers from the random distribution. So this is what we get. All right, and then I'm going to transform the time series by calling cumulative sum on it. And so we're going to get 0.94, and then we're going to add this, and then we're going to add this, and this, and this, right? So now this is what my time series looks like. And after 1,000 days, we're at a sum of 55. And you can just, so this is what my time series looks like. And you can just call plot on it, and you do ts.plot, and it automatically creates a plot labeled. Vertical axis is labeled, and the horizontal axis, it says, oh, I've got dates, January 1, 2000, January something, and it automatically kind of adds labels on the dates for you. So here's another example. So here I've done something very similar, right? So I've taken my time series index, okay, the TS, and we're going to just take the index, which is basically the dates here from 2000, January 1, 2000 to September 26, 2002. I'm going to call the columns A, B, C, and D because I was not feeling creative. And here is, in each column is just a bunch of random normal numbers, but then I do cumulative sum, and so now each of these will be kind of a thing. And so if you call plot on the data frame, so you do, so here we initialize a figure, and you can specify, you know, the figure size and things like that. And you can just say df.plot, and it will create a plot, the 4 time series for you right there. There's a legend automatically created. The axes are already labeled. You can add a title if you want and things like that. But it's kind of, it's very handy. You just, you just say, here's the data frame, and make a plot, dataframe.plot. And pandas will look at it and try to create a plot for you. Okay, the default is to kind of join the dots or the values inside your data frame with a line, and so it works very well for a time series here. Okay, you can also call plot kind equals bar, and so here's like one row from the data frame, and so I've got -0.9, -0.5, -4, and +0.2, and this creates a bar plot, okay? We're used to seeing bar plots that are only positive, but here you can say, so here is just, you know, kind of one row, and we want to make a plot, kind equals bar, and this is what the resulting bar plot looks like. Here's just a data frame. Can you handle an irregular time series when plotting, like stock prices where you don't have the weekends? Yeah, so let me think. I'm pretty sure yes, and I think it will just kind of, so it depends on your index, right? So if your index doesn't include the weekends, then I think it'll plot just fine. I think if your index includes the weekends, so you have missing values or something, I think it'll also reflect that as well. So you'll have to kind of play around with it, but I think it'll just it just kind of puts the index on the horizontal axis, and it plots it accordingly. So if your index is missing some dates, it will just, like, I think if your index jumps from like 2000 to 2005 and you got a 4-year span, like, it's just going to ignore it, and I think it'll just kind of plot them, but I'll have to check, double check there. Okay, so here's just a data frame with some integers in here, and you know, I don't know what this is. Maybe these are like types of cars or something, I don't know, right? So California has 3 of 1, 9 of 2, 4 of 3, 4 of 4, and 9 of 5. I don't know, whatever that means, okay? I'm just making up stuff here, okay? And what you can do is you can say, make me a bar plot. So you do do a data frame plot.bar, and here you go, right? Here I added a title, type by state. It adds the legend automatically. Again, you can ask for the legend to go outside the box. And so this is what we have. So we have California for type 1 has 3, for type 2 has 9, type 3 there is 4, and so on and so forth. And so, or for type 1, 3 from California, 5 from New York, 8 from Texas, and 1 from Ohio, right? And that's what we have, 3, 5, 8, and 1. Okay, so you can see it gathered this way. If you wanted to gather it the other way, what you can do is, oh, I messed that up. You can transpose it. Okay, so here is, you can just transpose the values, okay? So here, so here's the thing, and by default, when you call plot.bar, it's gonna kind of gather them by the rows. So we got 1, 2, 3, 4, 5, and row 1 has 4 values: California, New York, Texas, and Ohio, right? You can also, you can transpose it, and then it will kind of gather it by the columns here, right? And so it'll say California has types 1, 2, 3, 4, 5, right? New York has types 1, 2, 3, 4, 5. So you can do type by state and state by type, and so that you just transpose the data frame. Okay. Similarly, you can also create a stacked bar plot. All right, so this has the same information as this, except we've taken the bars and we stacked them on top of each other. And so this is what we have. Likewise, you can transpose it and create the stacks, right? So here we've got 5 bars with 4 colors each, and here I've got 4 bars with 5 colors each, right? Same information is conveyed in both plots, just how it's presented is a little bit different. So we got this and this. And this was just a silly thing I did, right? So here I'm going to do random int 1-7 to kind of simulate rolling a die, okay? And if I do this a whole bunch of times, you know, the min is 1 and the max is 6, and it's fairly uniform, right? And then if you do 2 dice rolls, so if I take the random values in dice 1 and the random values over here and add them together, we get a triangular distribution. df.plot kind equals bar and dfplot dot bar. Here, let me see. Sometimes I forget. So let me try this thing. So this is what we have here. Sometimes you run into errors, so we'll do plot kind equals bar, and we get the same thing. Yeah, okay. So I don't think there's a, so in this case, there's not a difference. Sometimes you think something will work, and then you get an error, right? This is a very common occurrence, right? So sometimes you're like, oh, I remember making a bar chart just by doing this, right? So you might try doing something like, you forgot what it was doing, and you say like, you do like bar plot, right? And then you go, oh, that's not right. Data frame has no attribute bar plot. So you go, oh, how did I do this, right? So you have to remember, so what's important is you remember what it is that you are trying to do, right? So here I'm trying to create a bar plot directly from a data frame. So I'm not going to search matplotlib in Google. I'm going to search pandas data frame bar plot, okay? Because if you try to do matplotlib, so you have to kind of think like what it is that you're trying to create a bar plot from, okay? And here we're calling it directly from the data frame. So you want to type in pandas data frame, okay? Pandas data frame bar plot, and then you go, oh, okay, this is what I need to do. So pandas.dataframe, this is basically df2 is a data frame object. So that because this is the notation, right? So it's going to, df2 is a data frame. So that's the name here. So we got df2 is a data frame object, and we're going to do .plot.bar. Okay. So we can do this and look at these other things, right? We can do .plot, and then here are also some other things that we can do. So plot.bar. Here are the different options, and you go, oh, subplots equals true, and you go, oh yeah, let's try that. Okay, so so the important thing, so we're going to do plot.bar, and we're going to do subplots equals true, and we get this, right? So so kind of it tries to do stuff, you know, as you've asked, right? And legend location equals 2 and stuff. So so all of these things, because there's too many things to try to memorize. All right, so don't feel bad if you can't remember anything, because I can't remember anything. Just you go on Google, but you just have to remember, am I calling this from a pandas data frame object? Am I trying to create a plot from the start, right? So over here, all of these things start with PLT. PLT is matplotlib PLT, right? Pyplot, right? And then the other things are data frames down towards the end, where I'm calling it from a data frame. So you're going to search for pandas data frame. So so anyway, that's it for today. Did I make a attendance quiz? I did not make an attendance quiz. What should my letters for today's attendance quiz be? All right, we'll go A and A. Okay, we'll do that. A and A. So I will make attendance quiz, and your two answers will be A and A. I will do that right now. Okay, that's it for today. Thanks for watching. We'll see you guys on Friday.